Welcome to lesson 4. In this video, we're going to be talking about geometric sequences. And so just to compare, last time we talked about arithmetic sequences. So in arithmetic sequences, as a reminder, is where you add or subtract some number to get to your next term. In contrast, a geometric sequence is when terms are found by multiplying the term before by some number. So where arithmetic sequences was when you add or subtract, geometric sequences are found when you multiply to get from term to term. Just like arithmetic sequence had something to tell you how to get from term to term called the common difference. So when you added or subtracted, we called that the common difference. With geometric sequences, we're looking for the common ratio, or we call that R. And that's the quotient of consecutive terms. So when I divide the two together, A over B. Let's look at just some examples and talk about the common ratio for just one moment. Hold on. Okay, so looking at this sequence, this top one, take a moment and identify what am I doing to get from term to term in this sequence. If you said multiply by 3, you are correct. So to get from term to term, I am multiplying by 3. Because I'm multiplying to get from term to term, this is a geometric sequence. Geometric sequence. Looking at this second sequence, take a moment and identify what am I doing to get from term to term. In this example, to get from 7 to 14, well, I could either multiply by 2 or I could add 7. Let's see which one holds true. To get from 14 to 21, okay, I'm adding 7 again. So I can ignore my multiply by 2. So I'm going to keep adding 7. The pattern holds true. And so because of that, what type of sequence is this when I'm adding a number? Great, this is actually an arithmetic sequence. Take a moment just as a reminder, and I want you to write the explicit form for this sequence just before we jump in. Okay, so the explicit form for this one is going to be my u sub 1, which is 7, plus n minus 1 times my common difference, which is also 7. So that would be my explicit form for that sequence. But we are going to continue to talk about geometric sequences now. So when I'm multiplying to get from term to term, and when that happens, I've got a common ratio. So to find my common ratio, like I said before, you're going to take the quotient of consecutive terms. So what that means, my consecutive terms, consecutive means they're next to each other. So for example, u sub n over u sub n minus 1. Or I could do u sub 2 over 1, where 2 comes after 1. So what this won't be, you don't want to do u sub 1 over u sub 2. That won't work. That'll give you a different common ratio. We'll talk about what to do a little bit later when you don't have consecutive terms, but you just have two kind of random terms and you need to find the common ratio. So let's look at these two examples. So in this first one, I've got a bunch of terms and I want to figure out what am I doing to get from term to term. So I can take any of these consecutive terms, so pick one of them, and you're going to divide it by the term right before. So for example, I could do 20 over 5. I could do 80 over 20. I could do 320 over 80. And you can simplify any of these fractions. Go ahead and simplify. And for all of them, you should get 4, which makes sense because to get from term to term in this one, I'm multiplying by 4. Okay, take a moment to set up this one. So I've got 7/3, 7/9, 7/27, 7/81. Pick 2 terms. I don't care which one they are, as long as they're consecutive. And you're going to divide by the term before it. So let's say I picked just my first and second term, so I've got 7/9 divided by 7/3. When I'm dividing fractions, it's actually a little bit easier to write it out horizontally, so that's 7/9 divided by 7/3. Take a moment and reflect, what do you remember about dividing fractions? What do I have to do after I've written it out linearly? Hopefully you remembered that you have to keep, change, and flip, so I'm going to keep my first fraction, 7/9. Change division to what? Great, multiplication. And then I'm going to flip my second fraction, so instead of 7/3, it will become what? Fantastic, 3/7. When I'm multiplying fractions, how do I multiply them? If you answered multiply straight across, you are correct. So this will be 21, not 7, 21/63. And I can simplify both of these numbers, hint, hint, by 7, so that I end up with 3/9, which I can keep on simplifying, divide by 3 to 1/3. And 1/3 will be my common ratio for this. So to get from 7/3 to 7/9, I'm going to multiply by 1/3. Okay, going back over here, let's talk about some of our formulas. So just like the arithmetic form has or can use the recursive form, so can geometric sequences. So it's going to be the same thing pretty much, except, so I'm still going to have u(1) equals. I need to know my starting term so that I can know where to start. But the second piece, instead of adding or subtracting a difference over here, instead I'm multiplying by my common ratio. So I'm taking, to find any term, I take the term before it and multiply by that ratio. So if I'm starting off with this sequence, 2, 8, 32, take a moment and identify what is the common ratio of that sequence. What am I doing to multiply from term to term? To do this, you can take u(3) over u(2), so 32/8. 32 divided by 8 is going to simplify down to 4. So my common ratio, or what I'm doing to multiply from term to term, is 4. When I'm writing my recursive sequence, this should become pretty easy at this point. I need to list my u(1) and u(n). My first term in this sequence is 2. And then with u(n), I'm taking u(n) minus 1 on the other side. And because I'm multiplying from term to term, I'm going to take u(n) minus 1 and multiply it with 4. Take a moment, take a look at this sequence, 3, 6, 12, 24. And I want you to write the recursive form of this sequence. Okay. Moving right along. If I want to write the explicit form, so last time we talked about the explicit form for arithmetic sequences. So this is really useful. What if I gave you this first sequence up here, and I told you that I wanted to find u(100)? Well, that would take a really long time to find. I want to have a shortcut, and that shortcut is my explicit form, EULA. So in geometric sequences, so when I'm multiplying from term to term, the formula is going to look a little bit different. It's going to be u(n) equals u(1) times my common ratio to the n minus 1. So n minus 1 is an exponent, whatever this value is. Let's take a look at an example problem. So let's say that I have u(1) and I have u(2). and I want to know what is u sub 5. So that would take a little bit to figure that out. So I want to find the explicit form for this sequence. So in the end, I should have u sub n is equal to u sub 1 times r to the n minus 1, with the only variables left in my formula being n. So I already know what u sub 1 is, but before I can fill this all out, I also need to know what r is. So I'm going to take my two consecutive terms, u sub 1, u sub 2, and divide them. So I'll have 3 over 4, and I'm dividing that by 3. So again, writing this out linearly or horizontally is helpful. Negative 3/4 divided by 3. What do I do next? Great, I'm going to keep change flip. Negative 3/4 times 1 over 3. So that was a 3 over 1. Multiply across, what is my common ratio? You should end up with negative 3 over 12, which will simplify down to a negative 1/4. Okay, now that I know that common ratio, I also know u sub 1. So I'm going to plug those both into my formula. I'll end up with u sub n is equal to 3 times negative 1/4 to the n minus 1. Okay, so my question originally was what is u sub 5? So I'm going to take a moment and sub in 5 for n. So u sub 5 is equal to 3 times negative 1/4 to the 5 minus 1. That's going to equal 3 times negative 1/4 to the 4th power. So when I have negative 1/4 to the 4th power, if I expand that out, I'm going to have negative 1/4 times negative 1/4 4 times. Okay, well I know that 4 times 4, that's going to give me, I'm multiplying just straight across. 4 times 4 is going to give me 16. And these are all going to become positive. So I'm going to have 1/16 times 1/16. Take a minute to yourself. You can use a calculator, 16 times 16, or you can work it off to the side. My u sub 5, or negative 1/4 to the 4th is going to be 1 over 256. So this is 3 times 1 over 256. Again, I'm just multiplying fractions. When I simplify, u sub 5 will equal what? Fantastic, 3 over 256. And if I wonder about whether or not 3 can go in, I know that it won't, because to get to 256, I only multiplied 4s, and 3 does not go into 4. So this will not simplify if I consider my factors of 256, or what multiplies to get to it. Okay, let's look at another problem. I would like you now to write the explicit form of this series. If I give you u sub 1 is equal to 2, u sub 2 is equal to negative 2/5. I want you to find what is u sub 5 using your explicit formula. Okay, I'm going to walk through this problem. If you solved it correctly, I apologize that you have to watch this again, but just bear with me, I'll go through it quickly. So to find these two pieces, I need to first find my common ratio. So I'm going to take negative 2/5 divided by 2. That's really going to be negative 2/5 divided by 2. Keep, change, flip. I'll have negative 2/5 times 1/2. I can simplify now, or I can simplify later. This will become negative 2 over 10, or negative 1/5. That's going to be my common ratio. So now let's get my explicit formula. I know that that formula is u sub 1 times r to the n minus 1. U sub 1 is equal to 2. So u sub n is equal to 2 times r is negative 1/5 to the n minus 1. And that's my formula. Now I need to find what is u sub 5. So I'm going to substitute in 5 for n. So I'll have 2 times negative 1/5 to the 5 minus 1, or 2 to the negative 1/5 to the 4th power. And so this time I'm multiplying negative 1/5 4 times. Okay, So if I multiply across, because I'm multiplying it an even number of times, I'm going to end up with two positive fractions. So this is going to be 1/25 times 1/25. Which when I multiply 25 times 25, I'll end up with 1/225. So here I'll end up with, here I'll end up with 2 times 1/225. And when I just multiply my fractions, 2/1 times 1/225, u sub 5 will equal 2/225. And that'll be my final answer. Before we move on, sorry, I just realized I made a mistake. 25 times 25 is not 225. It is 625. If you caught that before, good job. Sorry that I made that error. 625. Okay, looking at another type of example problem. So this is what I was talking about earlier when I'm not actually given consecutive terms. And I'm also not given my first term. So let's say that I wanted to find just what is u sub n, or what is the explicit formula between these two terms. So eventually I need to know what is u sub 1, and I need to know what is the common ratio. Let's start with the common ratio. So before with these problems, I would tell you to take consecutive terms and divide by the higher term by the lower term. In this case, we don't have consecutive terms, but we are still going to divide the larger term, or the higher term, sorry, so u sub 6, divided by the smaller term, u sub 3. So I'm going to take negative 5,120 and divide that by 80. However, I have to account for the fact that these terms are not consecutive. They're not consecutive. So I'm going to, and this might be a little bit confusing, so watch this over if you are confused. I'm going to consider this to be u sub 6 divided by u sub 3. And I'm going to treat my subscripts now like exponents. So on this side, we'll simplify this first. When I'm dividing exponents, I'm going to subtract my exponents, and in this case, I'm going to subtract my subscripts. So this is going to become u3. And now that I write this, I'm realizing that this is a little bit more confusing than I wanted it to be. So instead of doing this, we're going to do just a different variable, x to the 6th over x to the 3rd. So when I simplify those exponents, I'm just left with x to the 3rd. Okay, so you can ignore the u's. Sorry if that was confusing. On the other side, I'm going to simplify my fraction. So 5,120 divided by 80, maybe you've already done it before. 5,120 divided by 80. I'll end up with a negative 64, since this one is negative over here. Okay, so here's now where it becomes complicated. So I've got x to the 3rd is equal to negative 64. And that third power came from dividing my term numbers. So I want to just solve, this would tell me what to multiply to get from my first term to my third term. But I want to know just to get to my next consecutive term. So I'm going to have to take whatever this exponent is, I'm going to have to take its root. So I'm going to take the third root of x to the 3rd. Third root of negative 64. If you don't have a calculator at home, use your Chrome. If you log on to Delta Math from last year, it's got a great calculator that you can use. I'm going to use my calculator up here so that you know how to get to these things. If I wanted to take the third root on my graphing calculator, unfortunately there's no cubed root function. So if you look at all of the buttons and all of the values above it, there's actually no cubed root. In order to get to a cubed root, I'm going to press the math button, and you'll see one that shows up right here. If you need a higher root, you're going to use this function, and I'll explain that probably in another problem. So cubed root, I'm going to press 4 because it's tied to the number 4, and I'm taking the cubed root of negative 64. So in this case, x would equal -4, which is equal to my ratio. Okay, so that's my first piece. The next piece is that I need to know what u sub 1 is. What's going to be helpful is when I figure out the explicit form. So I'm going to substitute in what I know so far, which is just the ratio. So I'm going to get u sub n is equal to u sub 1 times r, or sorry, times -4. Wow, I didn't substitute anything in, to the n minus 1. Just like we did with arithmetic sequences when I knew a higher term, but I didn't know u sub 1, I'm going to pick one of these two terms and substitute in everything that I know about it into my formula. I'm going to go with the lower term because 80 is a lot easier to deal with than -5,120. So I'm using my u sub 3. So u sub 3 is equal to u sub 1 times -4. Since I replaced n with 3 here, I'm going to replace my same n with 3 up here to the 3 minus 1. So that will be 3 is equal to 80, so I'm going to substitute in 80 for u sub 3. It's equal to u sub 1 times -4. 3 minus 1 will give me 2. Okay, so at this point I'm going to expand my exponent, -2 or -4 squared. So 80 is equal to u sub 1 times a positive 16. I'm going to divide by 16. You can plug that into your calculator. I know that 16 goes into both. So u sub 1, so if I divide by 16, divide by 16, I'm going to end up with u sub 1 is equal to 5. So now I've got both pieces to my puzzle. I want to write my explicit formula. U sub n is equal to my first term, 5, sorry, not plus, that would be the explicit form for arithmetic sequences. So u sub 1 times my r, -4, to the n minus 1. And that'll be my final formula. Okay, one last problem that you are going to solve before you're done. U sub 4 is equal to 20. U sub 9 is equal to -640. I want to know my explicit formula. If you are still feeling stuck and you want to take a look at more example problems, you can always go into your book and look at the geometric sequences problem. Those problems start on page 58 in your textbook. So once you answer, take a look at those pages if you're still stuck, and we're going to talk a little bit about this on Monday.